Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Dogbo Jr., your math tutor and an instructor of mathematics at the University of Liberia. In my today's video, I will be discussing integral calculus. And on integral calculus, particularly I'll be looking at integration by parts. So an integration by parts is a method that is used to solve an integral problem that involves the product of two functions. So say we have x ln of x. So that's a product of two functions. We use integration by parts. Say we also have x sine of x, another product of two functions, or we have e raised to the power x times cos of x. Those are product of two functions. So you can have algebraic function, enteric function, algebraic function, logarithmic function, exponential function, enteric function. So whenever you have two functions combined, you can apply the integration by parts method to solve the problem. So consider that we have two variables or two functions that are all in x with continuous derivatives. So say we have u and v. Now, if we take the derivative of uv, that is, we say we want to take the derivative of uv, we're going to have u dv over dx, because we hold u and differentiate v, which is just dv over dx, plus we hold v now and differentiate u, will just be du over dx. So we want to get rid of this dx, we can multiply the whole thing by dx. So it's going to be du times v all over this. That's equals to this and this cancel. You have u dv, this and this cancel as well, plus v du. So now we can integrate both sides. So considering that we took du, it means this v is a constant, or if we take the v, it means this u is a constant. So we can factor out the constant, we'll be left with du equals the integral of u dv plus the integral of v du. So now this is just uv or vu equals to integral of u dv plus the integral of v du. So we want to make u dv the subject like we have in the equation. It means we have to send this across. So we have uv or vu minus the integral of v du equals to u du or dv. So this is the formula for integration by parts. Now let's look at few set of problems that you will always experience, like say the integral of x ln of x. So considering that you have an algebraic function and a natural logarithm function, how do you apply integration by parts? So we're going to solve a few other problems of different forms. So there's the first form. So the first thing we need to do is to identify our u and our dv from right here. What is our u and what is our dv? So our u now should be something that we will be differentiating, and dv is what we'll be integrating. Now let's look at the two functions, x and ln of x. Can we differentiate easily x and ln of x? The answer is yes. We can differentiate x easily. We can differentiate the ln of x easily. Now let's come to the integral portion. Can we integrate x easily? Yes. Can we integrate ln of x easily? No. So because integrating ln of x is a problem, we avoid allowing the v to be ln of x. So we just say u should be ln of x. Then the v equals to x. Now we differentiate both sides. The u equals to 1 over x, that's the derivative of ln of x, times the derivative of x is just 1. So we just attach dx. Now we integrate this out. So the integral of dv equals to, now this is this and this, right? So this must be dx. So it's just the integral of x dx. So if we integrate dv, we just get v. And we integrate x, we get x squared. You add 1 to the power and divide by the new power. Now we go back to the formula. The integral of u. What is u? U was ln of x. And what is dv? dv was x dx equals, what is u again? ln of x. What is v? v is x squared over 2 minus the integral of v, again x squared over 2 times, what is du? du is 1 over x dx. One over x dx. So that's how simple it is. So we notice that from the onset we had an integrand that involved two functions, algebraic function and a natural logarithm function. But after we apply integration by parts method, the problem was reduced to an integrand that comprises of just a single function x. So you see the reason why, or say of single function and algebraic function. So this is why integration by parts is actually important. So now we have x squared over 2 ln of x minus, so we can bring this 2 outside. We can reduce x and x squared, so it will just be x dx. So we have x squared over 2 ln of x minus 1 over 2 x squared over 2 plus some arbitrary constancy. Now we can factor out something common right here. So we know that 1 over 2 is common to the two of them. And we also know that x squared is common. So what is left here is ln of x minus 1 over 2 plus some arbitrary constancy. So this is how we integrate using integration by parts. So see you in our next lecture where we'll solve additional problems involving integration by parts. Thank you.